this thermal physics question, question number 13, which talks about a kettle heating a certain mass of water, and it brings it from T1 to T2, and then it takes a certain amount of time for it to come from T1 to T2. It's asking us to calculate the electrical energy supplied to the kettle, the heat energy supplied to the water from the kettle, and we need to give a few reasons. Well, it says one, but if I were in the exam, I'd write about 3 to 4, so it would match the one written in the mark scheme. So give one reason why not all of the electrical energy supplied to the kettle is transferred to the water, and then part B of it is all about potential difference supplied to the kettle in part A. So the part B is about the electrical circuitry. So it wants you to calculate the resistance through the values of voltage and power. And then part B is about resistivity. So that's how you break down the question. So the first part, 13A1, would be P equals E over T, where you divide 3000 watts by 320 seconds to get your answer in joules. The second one would be E equals MC theta T, where you'd multiply 4200 joules per kg per Kelvin times 2.5 kilograms to 84 degrees, and that's how you'd get your answer in joules. And then the reasons for why not all the electrical energy supplied to the kettle is not transferred to the water is because of efficiency problems of efficiency due to circuitry issues, magnetic heating, eddy currents, internal resistance, machine errors, and then you've got mechanical errors, mechanical hindrance, absolute errors, relative errors, systematic errors. So that's that part sorted. And on top of that, the part B is all about why and how to calculate the resistance from the power, given power. So you've got the power, you've got the voltage, you just need to find the current first, and once you've found the current, you then take power equals I squared R, you square the current and divide power by the square of the current, and you'll get the resistance. And then once you've got the resistance, you'll plug it in this formula R equals rho L over A to find out the resistivity. So you've got the resistance, you've got the length, you've got the area. Area would be cross-sectional, so it'll be pi r squared. But remember, please keep all the readings in meters. So you'll have to multiply. So you'll have to take L and A onto the other side. It'll be R times A over L. So it'll be a resistance calculated in B1 multiplied by pi r squared in meters, divided by the length in meters. That's how you get your answer. But make sure always mention the units at every stage of the equation processing, and then write the final units as well. And on top of that, write your numerical substitution clearly so that the examiner is going to understand what's coming out of your head onto the paper. Thank you very much. It was published in 2004, a very important question indeed.